Thank you for coming to Space Story. Please click subscribe, like, and notification. The universe between 9.6 billion and 9.5 billion years ago was undergoing a crucial stage of its early evolution. This period corresponds to the early phase of the cosmic dawn, when the cosmic dark ages ended and the first stars and galaxies began to form. End of the cosmic dark ages. Approximately 380,000 years after the Big Bang, the universe was a dark, expanding space filled with neutral hydrogen and helium. Because there were no luminous celestial bodies, this period is called the cosmic dark ages. Due to gravity, the density of these gas clouds began to show slight irregularities. Beginning of the cosmic dawn. Over approximately 100 million to several hundred million years, denser regions grew larger by attracting surrounding matter. These concentrated gas clouds began to collapse under their own gravity, becoming hot and dense enough to initiate nuclear fusion reactions. The first stars, population 3 stars, began to be born. These stars were much larger and hotter than the stars we see today, composed only of hydrogen and helium. The first stars emitted powerful ultraviolet radiation, beginning to ionize the surrounding neutral hydrogen gas. This process is called cosmic reionization. Formation of early galaxies. It is presumed that the first stars gathered to form the seeds of small galaxies. These early galaxies were likely smaller and more irregular in shape compared to today's giant galaxies. They gradually grew through active star formation. The universe 9.6 billion to 9.5 billion years ago. This period was likely a time when cosmic reionization was actively progressing. The universe gradually began to emerge from darkness and be filled with its first light. The first galaxies were in the initial stages of growing and merging to form larger and more complex structures. The universe was still rapidly expanding and cooling, but matter was gradually clumping together. In summary, the universe between 9.6 billion and 9.5 billion years ago was a very important transitional period, emerging from the tail end of the cosmic dark ages, where the first stars and galaxies began to be born and grow. The cosmic reionization that occurred during this period played a crucial role in the evolution of the universe into its currently observed state. The universe between 9.5 billion and 9.4 billion years ago was a significant period when the early universe gradually began to take shape. The first stars and early galaxies born in the previous period became more active, greatly influencing the evolution of the universe. Continuation of cosmic reionization. Cosmic reionization, which began around 9.6 billion years ago, is believed to have continued during this period. The powerful ultraviolet radiation emitted by the first stars progressively ionized the surrounding neutral hydrogen gas over wider areas. This process played an important role in gradually transforming the early universe from an opaque to a transparent state. Growth and evolution of early galaxies. The first small galaxies continued to grow more, maintaining active star formation. They increased their mass by attracting surrounding gas and dark matter. Mergers between galaxies are also presumed to have been active. Smaller galaxies combined to form larger and more irregular galaxies. These early galaxies likely had a more primitive form, different from the spiral or elliptical galaxies we see today. Active period of star formation. Active star formation occurred within early galaxies. A new generation of stars, with slightly higher heavy element content than the very first stars, may have begun to form. Stars during this period would still have tended to be short-lived and bright. Early stages of cosmic large-scale structure formation. Due to the influence of gravity, galaxies likely began to gradually cluster together to form larger structures like galaxy groups and galaxy clusters. The distribution of dark matter played a crucial role in the formation of these large-scale structures. The universe 9.5 billion to 9.4 billion years ago. The universe was gradually being filled with more light, and the appearance of early galaxies also began to become clearer. Star formation was active throughout the universe, and galaxies grew and evolved through gravitational interactions. This can be said to be a significant period when the initial outlines of the cosmic large-scale structure began to emerge. This period was an essential step in dispelling the darkness of the early universe and moving towards the complex and diverse universe we see today. The universe between 9.4 billion and 9.3 billion years ago was a time when the evolution of the early universe accelerated further. Early galaxies formed in the previous era grew into more distinct forms, and significant progress was made in the formation of the overall structure of the universe. Active galaxy growth and mergers. Early galaxies continued to grow larger and more massive by continuously absorbing surrounding gas and smaller galaxies. Mergers between galaxies were still active, and the shapes of the initially irregular early galaxies gradually began to diversify. Supermassive black holes may have begun to grow in the centers of some galaxies, potentially leading to active galactic nuclei, AGN, activity. Changes in star formation rate. The star formation rate may have begun to show a gradual decrease compared to the very early universe. This could be due to factors such as gas depletion within galaxies or suppression of star formation by black hole activity. However, active star formation still continued in many galaxies, with new stars of various ages and masses being born. Development of cosmic large-scale structure. As galaxies gravitationally attracted each other, galaxy groups and clusters began to form more distinctly. Dark matter still played a crucial role in the formation of these structures, and the initial outlines of the cosmic large-scale structure, where galaxies are distributed along vast filamentary shapes or void structures, became clearer. Completion stage of cosmic reionization. Cosmic reionization is estimated to have been nearly completed during this period. Due to the ultraviolet radiation emitted by the first stars and early galaxies, most of the neutral hydrogen gas in the universe became ionized, and the universe became transparent, allowing light to travel freely. The universe 9.4 billion to 9.3 billion years ago. Early galaxies became more mature and diverse, with some showing active galactic nuclei activity. While the star formation rate varied by region, overall, it may have shown a decreasing trend compared to the very early universe. The cosmic large-scale structure began to take on a more distinct form, and galaxies clustered together through gravitational interactions. The universe had nearly completed reionization and began to take on the transparent appearance we see today. This period can be considered an important turning point where the turbulent changes of the early universe gradually stabilized, and the basic structure of the current universe began to form. Thank you for watching the Space Story video. Please click the subscribe, like notification.